Thanks for being on the podcast, Jude. I appreciate you. I appreciate we've been trying to organize this. It's been a few weeks. You're the global strategy manager at Autodesk, a company that I'm pretty familiar with in terms of software, and I'm sure a lot of people that are listening to this podcast have either used it or they know about Autodesk, either the AutoCAD softwares, Revit, all the good things. So, can you tell us a bit, what do you do as the global strategy manager at Autodesk?
Yeah, definitely. So I think it's one of those roles that, again, if you come up through like an engineering degree program, it's not necessarily something you heard of, right? Strategy. It wasn't something I'd heard of until I joined kind of Autodesk and understood a bit more what that meant. And ultimately, I work within the education sector for Autodesk. And what I look at is what trends and shifts in either the industry of design, manufacturing, engineering, or shifts and trends in education, and what does that mean for how we are positioned in the market? What products should we have? What offers should we be giving to students? Making decisions on, for example, like new products, who should get access to those? And we'll get onto this in a bit more detail later, but something like generative design, which is a quite transformational bit of technology, that was a project that I ran of like, how do we get that into the hands of students? Like, what is the mechanism for giving it to them? How much should we let them use it? Should they be capped at all? And things like that. So it's a strategy role, but really you look at trends in industry and try and figure out, what does that mean for my business? And my business is engineering within education. So what does that mean? Like, the pandemic is a great example of this, right? Schools now have to teach remote. So all of the things that we used to provide, like lab installation advice for teachers and IT admins to deploy software, whether that's AutoCAD, Inventor, Revit, well, that's not necessarily how that's going to be taught now. They're not going to go to a lab, sit there and listen to a teacher. So do we even have what our customers, students and teachers need or not? And if not, what do we need to build? Who do we need to partner with, and how do we need to deploy that to make them get access to technology and learning content? And that's one thing as well about the role that I really enjoy, is it's not just like product, it's not just software, it's other things like learning content and tutorial videos, webinars. Like, how do people learn stuff? And for us, how do they learn technology? Because what we quite often find, which is unique to the tech sector, and you'll have seen this, as will most of your listeners, like, you have a teacher that doesn't necessarily have the requisite knowledge of that technology because it's moving so quickly, but it's not their job to know everything and teach it. So how do we as a technology company deal with that, where the student might know more than the teacher? Like, how do you help that teacher still teach it without knowing everything about that software? Because if you've opened Revit or Inventor or Fusion or AutoCAD, they're like massive pieces of software, and you may only use 10% of it. So expecting a teacher to know 100% of Revit and AutoCAD and Inventor and Fusion and other products just isn't going to happen. So, but that's what we kind of deal with as a strategy role, is what do we do? What's the new market? What's the new offering? Should we be active in this country, for example? You know, if you look at people that are taking on robotics, should we be doing more in those countries because they're more forward thinking than other countries? So it's a quite diverse role, and I really enjoy it. So it's equal parts industry of engineering, industry of education. So I quite like it.
How long have you been working at AutoCAD, and how has your experience been? You know, AutoCAD is one of the world's most innovative companies, and I don't think it's properly credited with the level of opportunities that it has allowed the world to achieve. You know, every single building in the world is designed in part using Autodesk softwares. So, like, how has your experience been working at this company?
Yeah, it's quite wild, because like I was a user of the technology, like a lot of people. I learned it at college. I learned AutoCAD first of all, then I moved into Inventor and other products like SolidWorks and Creo and things like that. And then I went into industry and used Inventor every day, which is a 3D parametric modeler, and designed factories and machinery. And then I started working with Autodesk as a consultant, doing some of their teacher training for secondary high school teachers. And then I got the opportunity to join about 6 years ago, and I joined the education team actually back then. And yeah, I think people, and this is the common mistake, right? Like, Autodesk is just AutoCAD, which isn't true. That was the first product, 1984, where that came out, and basically took drawing boards and drawing offices, as they were known then, like changed them from being paper-based and an incredible skill, and kind of took it to the computer, but not just like a big mainframe computer, but actually like a PC effectively. So it kind of unlocked that technology for everyone, because at that time there were CAD companies, like they weren't the only thing on the market, but those CAD packages did some like obscene mainframe computer that took up like 6 foot square just for the computer, and then this brought it to the accessible technology so everyone could use it. And then after that, you see other products like Inventor in mechanical, Revit in architecture and civil. And then also another thing that people don't credit Autodesk for necessarily is media and entertainment. So visual effects, computer games, that side of things. So that's, again, one of the leading 3D modelers there. And if you look at the Oscars for best special effects for the last, I think it's 18 or 19 years, all of them have been through Autodesk software. So it's quite a unique company where, and I think this is where Autodesk have a really strong kind of position in the market, is visualization software that was used to make, name your film, Game of Thrones, Inception, Avatar. Having the knowledge and the technology to do high level visualization and bringing that to architects or bringing that to mechanical engineers is really quite powerful. And likewise, going back the other way, when you start to want to do, accurate presentations in games, well, we've got all these architects, civil engineers, mechanical engineers that have that knowledge, and that way you can put more realistic things in movies, more realistic things in games. So it's kind of a nice blend that you get these, and we call them kind of vertical industries at Autodesk. So it's nice to be able to move between all of those and share best practices, and the more you look at it, the more those things are going to collide, right? Like manufacturing and construction is already colliding, and some really good companies are doing awesome things. So there's a project by a company called Mace in the UK where they were building a building, a skyscraper effectively, but rather than building it like a standard construction building, they actually had a factory floor, built floor 1, moved the factory up, built floor 2, moved the factory up, and that's kind of interesting that that's happening. Then the other side of that is automotive and gaming. Like those two industries are really close already. Like the use of VR to check the latest Tesla for how it looks, how it feels, and that's just going to keep going. So like Forza and Tesla are going to combine at some point, right? Like it's going to be the same thing, the same technology is going to be used, and that again is really cool that I get to see that at Autodesk. I get to work with game designers, car manufacturers. It's like quite a broad and you get to meet insanely clever people, which is part of it as well, right? You get to work with good people that are industry experts or have invented that thing, and that's cool as well. For me, it is anyway.
How often does Autodesk come out with a new product?
That's a great question. Depends on the market. So like for example, like manufacturing, it's maybe more or less than it is in architecture. And what Autodesk kind of has as a strategy is not necessarily like, let's just bring loads of products out and have loads of products in market. Our I guess the wider strategy is to consolidate that into a single product. And that's why Revit and Inventor and Fusion and AutoCAD are big products, because there's been acquisitions of technology that then gets embedded in. And there's a few reasons for that. One, from a technology stack point of view, that's easier to have like one big platform and everything looks at that. But secondly, for you as a customer or a user, like trying to figure out the difference between 400 products versus 3, that's the difference, right? And you can see this with a technology like Fusion. The whole idea of that is that's a platform from design all the way through to make. So like if I want to design and or make something, it's one tool. And ultimately, there's been a bunch of acquisitions that are public. There was a company called Delcam that is a CAM software company. So products like PowerMill, PowerShape, FeatureCam, all of that technology will be bought into Fusion. And the idea is it's one user interface, the data is in one place. Because how many times have you tried to export something from a CAD package and then import it to a CAM package and the link is dead and you made an update and it didn't carry across? Like that's stuff we want to get rid of. We want to make it as easy as possible for anyone to say, I want to make this thing. And okay, well, here's one platform, here's one product, and you can go in there and use that. So Fusion is, is young compared to Inventor, SolidWorks, Creo, but is still, 8-10 years old from when it first came out. But the idea is that will be where everything sits. And one day, hopefully, there will be one product for manufacturing, one product for game design, one product for construction, rather than tons. Because if we look at like education, how hard is it to learn user interface for 5 different products? Like it's 5 times harder than just learning one. So yeah, that's, I guess, our dedication to the market, is make it simple and easy to use. And that's always been what Autodesk have done, right? That started with AutoCAD. It's like, how do we make CAD easy and accessible? And that's exactly what we're doing with Fusion, is how do I make CNC machining easy and accessible to a 12-year-old roboticist like Mike, right? How do we give him the tools he needs to be successful?
You know why I asked this question? It's because what you said earlier about the gaming and a lot of the visual effects that come out of gaming are results from renderings and designs created on Autodesk, which is something I didn't know about. For example, for me, Autodesk was, I come from the engineering background. So for me, I knew SolidWorks, I knew AutoCAD, definitely AutoCAD because I come more from a civil engineering background, a bit of Revit, but it's super interesting to see that there's just so many softwares. And actually preparing for the podcast, I was going through the list of AutoCAD softwares, and to be honest, 80% of them I have never heard of them before. Like maybe Inventor, I've seen it, but I never experienced it. But the other 80%, it's like I can just imagine to how many people and to how many industries you tailor. It's not like you're a construction company that offers construction software. You literally hit every industry. And that's what makes AutoCAD so groundbreaking in a sense, where literally the world was designed on AutoCAD, like the entire world.
Yeah, it's quite bizarre, right? And I don't take that lightly when I joined the team at Autodesk, right? It's like, it's insane that you brushed your teeth. Well, hopefully you brushed your teeth this morning. That probably went through Autodesk software. You watched Game of Thrones on Netflix last night. That went through Autodesk software. Like the house you're in or the building you're in probably went through Autodesk software, depending on its age. And that's quite like an insane thing when you think about it. And you realize, and again, it's not Autodesk, right? It's the customers of Autodesk that do this awesome stuff. I just want to be clear, like we provide the tools to let companies make amazing things, whether that's building, sports cars, movies. And that's something as well that I really love about working with students, is you build a software, a tool, a feature, whatever it is, with one intent in mind, that is, I'm building this tool for game designers. And then suddenly architects pick it up and go in a crazy direction and create these insane visualizations. It's like, oh, cool, I didn't think that was going to happen. And actually, you see that with rendering quite a lot, right? Like architects took on VR quite early to represent what that building would look like for customers. And that technology probably wasn't thought of for architects. It was more like, how do we build a more immersive experience for gaming? Or how do we build a more immersive experience for designing stuff? And then, some architecture firms were like, well, actually, this is perfect for me to show my customers rather than use it as a design tool. It's more of a exploration tool. And that's where it gets really interesting. And the benefit of Autodesk being across all those industries makes the product better, because rather than being a civil engineering company that's trying to make, a rendering add-in for something that you've used, it's like, well, cool, we've got like world-class rendering engine over there in 3D Studio Max or Maya from the game and visual effects. Let's just bring that in. And then one, it makes the technology stack easier to manage, and there's experience of it, but also it's world class already, so you don't have to build something from scratch. So it's an interesting company in that respect.
Can I jump on that thought for a second? And before we move on to talking about the more side you specialize in more, which is education, there's one thing I'd like to jump on here, which is mainly for the viewers, for the listeners actually that are listening to this. I watched a video this morning. I was doing research for the podcast basically. And I saw that there was actually Autodesk made a mini documentary on YouTube that was published about a building it's a world-class building that's literally 100 meters away from my office here at WeWork. It's called the Museum of the Future. For the people listening to the podcast, it's called the Dubai Museum of the Future. And when I it's like when you see the building, it's really ridiculous how they designed the building, and it just shows the power of Autodesk softwares. It's like if you can imagine the building, it's like an oval, a 3D oval, imagine, with literally a hole in the middle, and there's no windows in the building. Instead, there's like Arabic calligraphy on the building, and those calligraphies are the windows. And parts of the building were 3D printed because you can't like design such a round shape using traditional manufacturing. So that's really something I invite like the listeners to like just look at the pictures on your phone. It's really gonna inspire you like how beautiful this is. But moving on to the next topic I want to talk to you about. You're big on education. You know, every single LinkedIn post you have on your LinkedIn is related to education. Why are you so interested about this specific topic?
Yeah, it's a great question. I think part of it's like nature and part of it's nurture, right? So from a nurture point of view, I'm from a family of teachers. So my father is an instrumentation engineer. My mother is a primary school teacher. I've got two sisters that are teachers. So like education has always been like around when I was growing up. But for me, it's more of a personal journey, which is I went to a standard kind of middle high school in the UK. And I didn't even know that, other than what my dad told me about engineering, like I wasn't really guided towards that as a path, right? It was where I was from, the aspirations of people from that school were just whatever was local. And there wasn't a massive engineering output nearby. The only thing there was a nuclear power station. So I ended up going there and doing what's called an apprenticeship in a nuclear power station. It's called Hinkley Point. So for those of you that are in Europe, you've probably heard of Hinkley Point C, which is a new power station that's being built. So that's where I kind of started my life. And if I'd known perhaps earlier in my career what engineering was, what the different facets were, like you could be a designer, you could be a manufacturer, you could be an installation person. So I actually started in like maintenance, installation and repair of equipment at that power station that's probably 40 years old. And then I was doing, and this is like why for me it was kind of natural to want to work at Autodesk. So then I was doing night school to learn CAD because I did one unit on that as part of my maintenance job, which is basically reading drawings. And then I was like, oh, this is cool. So then I started doing AutoCAD in the evenings, like night school twice a week after work. And then I did 3D in AutoCAD, which was more difficult than it needed to be. And then I did 3D in SolidWorks, and then I did 3D in Inventor. And I did all of this night school and was like, this is awesome. I wish I could just design stuff all day long. And then I ended up moving and becoming what's called in the UK a design engineer to another company. And that, had I known that when I was 12 or 13, that was an option, I would definitely pursued it. And what I realized is it was like I don't want to say a failure, that's the wrong word, it's quite strong, but a failure of the education system, which is all you can do to be successful is study English, physics, chemistry, go and do a degree in English, physics or chemistry, and then do something with that. And most of the people in school were like, you should come back and be a teacher. Like because that's what they know. And I felt that after engineering had given me so much, like it gave me social mobility, I was able to, get my own place to live, buy things I wanted, all of that nice stuff. I was like, I need to give this opportunity to more people. So probably for the last 8 or 9 years, I've been more focused on education and helping people understand what a career in engineering could be, or that robotics is a completely valid option for those people at that school. So I do work with my old school and I work with my old college to try and help people understand that there are many ways to success. And it's not just lawyer, doctor, and all of those other really well-known, high-paying jobs. That's not, I actually think if you work in tech or engineering, you probably make more money than most doctors. My wife's a doctor, and lawyers. And probably you're working on, in my opinion, cooler stuff, right? So it's one of those weird things that, for me, going to school, like the ultimate aspiration was to, the only thing that we knew was, you can be a doctor or you can be a vet and all these things. It's like engineering has got so many different career opportunities and so many different avenues that you can go down. You can start designing buildings or products or motorbikes or cars, and whatever you're interested in, there's an engineering job for you. And that I think is a failure of the system that I'm trying to fix by focusing on education.
Before we started recording the podcast, you had mentioned something really interesting, which was that you think that the way people are gonna get educated this decade is about to change, where we're gonna start seeing traditional education, or actually traditional way of education in terms of knowledge transfer, is gonna change fundamentally in the next decade. Can you expand on that, please?
Yes, I think from like a historical point of view, and this is true for pretty much every major university and college, is it was like a knowledge economy. So you got paid for knowing X, whether that's engineering and memorizing equations and knowing laws and fundamentals of physics. You got paid for knowing that because you had to read it from a book. You had to learn that, understand it, and be able to apply that somewhere else. But within the last 2 decades, that has become a commodity. So that's no longer something that will get you a job. Like Leon graduating with civil engineering, meaning he knows this and this and this. I'm not going to pay you for that because I can look that up on the internet, and I can get someone that hasn't had an engineering degree to look up what that law is or what that theorem is and apply that calculation. Or better still, there's a software that does it for me. Like you think about all the Autodesk software, what that's trying to do is take away having to do hand calculations and putting it into a software with a nice user interface that says, how long is it? How much force is it going to see? And I'll tell you the answer. And that's the difference in where we are now. It's not a knowledge economy anymore. It's more of either a skill-based or, and Navid was touching on this, is it's more of like it's the way you work that you're going to get paid for. So things that are harder to kind of put down, like innovation or problem solving or collaboration, that's what you're going to get paid for now as an engineer, not remembering that thing. And if you look at companies like Neuralink, right, that is the nth degree of this, which is scary and awesome. Like it'll be like the Matrix. Like if I want to learn Kung Fu or how to fly a helicopter, I don't need to physically learn it anymore because I can get that fact from the internet and it will potentially be linked to your brain. So for that to be true, like what value is there in education if I can look anything up and do anything? And it's not necessarily about regurgitating that fact or knowing that thing. It's about how you apply it, how you work with people, how you apply that to an industry. And that's where I think fundamentally, and everyone will have seen this meme, right? Of like, here's a school lecture theatre in pick your year, 1600, and it's tables and somebody at the front of the blackboard. And like the lecture theatre now, exactly the same. And that, if you then look at the product or the world we live in, you just mentioned the Museum of the Future, like look how different that is compared to a house from the 1600s. It's insane. And why is education not changed? And that's again why I've been involved, is from industry. I've learned a lot of the stuff I've learned has been on the job or physically making something or designing something. And I think the format of me, the teacher, and I know everything, and open your minds and let me fill it up with knowledge, I don't think that's going to make successful engineers. I don't think that's going to make successful companies. And you can see that, right, by all the people that are successful. It's not like they're the most knowledgeable person in that sector. And, we were briefly speaking about Mike and how he's the next Elon Musk. Like, look at Elon Musk. He's not, well, he is, I guess, now by de facto, but he's not a rocket scientist and he's not a fintech person. But guess what? He has companies in all of those sectors. And it's not because he knows everything about fintech or everything about rocket trajectory. He just applies that way of thinking, innovation, design thinking, to those industries and changes it. Like I've just ordered Starlink, which is their Wi-Fi through satellites. I have satellite connection now. It's atrocious. And they don't care about me, the user. Like to set it up, I had to ring somebody and they had to come out and install it for me and, tweak the satellite and all this stupid stuff. Whereas what Elon and all those companies have been good at is focusing on the user experience. And like, what do I expect as a millennial that has a smartphone? Like, I want to be able to do everything on that phone in the app for Starlink. So I can take a picture of where that needs to be and it will tell me, well, you need to tilt it 5 degrees this way. So what they're doing is they're kind of de-skilling and making that accessible to everybody. And that's what we need to do for education as well. Like, why would I teach somebody, and there's a really good book on this called The Sabertooth Curriculum, which is around like, do we still teach people that at university that if you see a saber-toothed tiger, you should run away from it? No, because it's not relevant. So why do we do the same for whatever it may be, fundamental maths or physics? I understand you need to be numerate and be able to work with numbers, but you don't need to necessarily remember that law and in an exam not have it written in front of you, because where in the real world are you not going to be able to Google what that theorem or calculation is and be able to apply it? It's not going to happen. The same is true for every industry, medical, right? Like, how many times have you been to a general practitioner and they're like, oh, I think that rash might be this. Let me look it up on the computer. That's normal. Why would you expect people to know all this stuff? And I think there's good and bad sides of that, right? Like, as engineers, the fundamentals that you may have known with a degree from 20 years ago, you may have had a way better understanding of how to build a computer from the ground up. Whereas now, you just know you need a motherboard or you need a microcontroller or whatever it is. So there is arguments that says if everything went bang and we have to start from scratch, it would be really difficult with the way we're set up now. But you can see as well, this is like the trends in industry, like what is the value of a 4-year degree? Other than the experience and the learning, like, can I learn? And this is what the pandemic has shown us, right? This is a prime example of universities have known forever, for like the last 100 years, they need to probably change the way they teach and allow for those technologies like what we're doing now, remote learning, remote lecturing, but they've just not needed to because everyone kept going. Whereas now, if I was starting to look at university and everything will be online, why would I pay, depending on what country you're in, the UK it's 9,000, the US and Canada could be hundreds of thousands. And why would I do that if I can do another way of obtaining that knowledge and proving that knowledge? And that's what you see in other tech companies. Like Google have brought out something called a career certificate. I don't know if you've seen that, but effectively it's a 6-month online course, and they will consider, if you've got their qualification, they'll consider that equivalent of a 4-year degree in, and they've got 4 of them. I think one of them's experience design, project management, and a couple of others. So as and as a financial kind of model as a student, like that would be cheaper, quicker, and I get the job I want. So why would I pay more, spend more time? And that's what I think you'll see more of. And Autodesk has certification, Cisco has certification, Salesforce has certification. And I think what you'll see is, depending on your industry, as well as a 4-year degree, which is now a commodity or a table stake potentially in your country, you'll need something else. So I've got a mechanical engineering degree, but I also have a Fusion 360 certificate that says I understand digital manufacturing, which is more niche and more kind of focused than a mechanical engineering degree. And if you're going for a digital manufacturing job, I think you'll need that in the future. And then what you'll see is, as those certificates become more commonplace, then people will question the value of the degree even more. And I think universities really, really need to figure this out in the next academic year as to what they're going to do, because you've already got students deferring, right? There's a big trend, especially in the US and the UK and other parts of Europe, which is, if I can't do labs and I can't go to parties and meet people, why would I go? I'll wait until next year and there's a vaccine out and I can do all of that stuff properly. And that's already happening now. That's only deferral. But the next logical step is not bothering at all and doing it online. And I think you'll also see a rise of like independent training companies where you can go and learn that knowledge and that experience, and you can apply it straight away within a company. So things like apprenticeships that years gone past were like really popular and now gaining a lot more popularity especially in the US with tech companies. It's like, well, let's just bring people in straight from high school and teach them the way we want them to think, and give them that on-the-job training. So I think you'll see a big rise in apprenticeships as well across the US and things like that.
Oh man, you hit on so many good points right now. I don't know what to choose. I'll go with this one. You said something very nice, which is that we're shifting from a knowledge economy to a skill economy. So in your opinion, what do you think are some of the most important skills someone should possess to thrive in the 21st century economy?
Yeah, so I thought about this long and hard, because this is kind of part of my job, right? It's like, what would that look like? And how do people acquire those skills? And behaviors as well is another one that we talk about. So there's knowledge, skills, and behaviors. And one of the things I think, especially for engineers, like ultimately it's problem solving at the very highest level. And then I'm kind of focusing more on mechanical engineers when I say this next stuff, but I kind of try to broaden it as much as I can. So the big one for me that I think is massively underrated, especially by engineers, is design for manufacture. We've just spoke about buildings, cars, products, like nearly every company. I can't think of many, it's probably like 0.001% that get paid just for a design on a screen. Everyone else has to make something, whether that's a website, an application, a car, a building. So understanding how you can take something from design through to manufacture is one of the most valuable skills you can have as an engineer, because ultimately that thing has to be made to get into the market and for you and your company to be successful. And how often have you seen, and I've backed loads of stuff on Kickstarter previously where someone's done an amazing design and an incredible video, and I've gone, yeah, that's wicked. I'm gonna buy that, and I've given them money, and then it's taken 3 years to deliver because they didn't realize that for injection molding you need to machine a tool, and that costs a lot of money and takes a lot of time, right? Like I've seen that so many times where people don't understand the difference between doing a one-off prototype and making 1 million of that thing. So that's really understanding all the manufacturing processes that are available to you and using the one that's correct. And again, I see this a lot at the university where people will 3D print a cylinder. So why didn't you just get a piece of bar or tube off the shelf made of metal or wood or whatever it may be? Why there was no need to 3D print that. And that's the difference, right? Of if you understand the manufacturing process, you might have chose something different and ended up with a better product. So that's one of them. And I've kind of got, ultimately it's like 4 things. So that's number 1. Number 2 is using, and it's either AI or machine learning, depending on what fraternity you come from, but workflows where you're augmented by the computer. And we briefly touched on something called generative design. That's a perfect example of this, right? So if I make products, I've got a water bottle here. So I'm a cycling company, I make water bottles, and I want to do a new design of that. As an accomplished user of Fusion, I could maybe design one in 4 hours. I could maybe run a simulation of it in an hour. I can maybe 3D print it and test it. That's another hour. So in a day, I might be able to get through 1, maybe 2 iterations. And that's kind of what we've been used to. So every product that's in market right now has maybe had 4 or 5 iterations. If it's something more high profile and, on the iPhone is on iPhone 12, that's had a lot more iterations. But for a brand new product introduction or NPI, it would have been through minimal iterations. Now, what you've got with cloud computing, machine learning, AI, and what you can do is I can only model and simulate as much as I can in one day. Whereas if you've got cloud compute, you can model and simulate simultaneously, first of all. And secondly, you can do it tens, hundreds, thousands, millions of times all at once. So rather than having 3 iterations before that product gets to market, it might have 10,000 just by nature of using the cloud and using something called generative design, which is ultimately what you do is you say, here's my interface points, here's the area that I don't want geometry, and then the computer will go away and model every possible permutation of that product. And then what you can do is you can select based on what's important to you. So for example, there'll be things like manufacturing time, cost, or material used, whatever it may be. And let's say, let's take an example from like Formula One or NASCAR. Cost is probably less important to you than efficiency of that product. So you might choose the one that costs tons of money, but is the best product. Whereas I make a commodity product of water bottles, so actually cost and manufacturability is more important to me than actually the end look of that product. So it allows you, the user, to kind of co-collaborate with the machine. And that is the big area that, going back to education, that's what we're not teaching. Like, you're not going to get paid to model, simulate, prototype and iterate, because a computer will replace you doing that. And we need to be honest with ourselves as well with that there are things computers are better at and there's things that humans are better at. So understanding the problem and using design thinking and making sure we're solving the right problem, humans are amazing at that, computers less so. What about, just creating geometry? So in the simplest form, using CAD, doing an extrude or a revolve, that's not value add by a human. A computer can do that way better than I can, and quicker and more efficient. So let's be real with ourselves, and how can we co-create stuff with machines that we use their strengths and we use our strengths. So that's that's like number two. So number one is design for manufacture as a skill. Second one is like being able to collaborate with a machine or with a computer. The third one, and this is where we get into like cross-industry, systems thinking. And there's a couple of ways that this can be explained. And there is some really good degrees, right, called advanced systems engineering or integrated systems engineering, but they quite often focus on mechatronics and electronics and controlling of systems. Whereas what I'm talking about is understanding the system, and cradle to grave is a common term used for this, which is the full product life cycle. And you can see this with innovative companies that use byproducts of other companies. So there's a waste material that comes from the manufacture of petroleum. So how can I use that material as a value add somewhere else and actually be a net contributor to the system? And there's something called the circular economy, which is a really interesting concept that if people aren't aware of, they should look it up. There's a really good video that's about 4 minutes long on YouTube. It's by the Ellen MacArthur Foundation. But a good example of this would be, so I'm assuming most people have bought ice creams growing up, and they come in a little paper wrapper or plastic, unfortunately. So that's another misconception. Plastic's a great material when used properly in a systems context. But that's the example. So you have an ice cream, a lolly, an ice pop, whatever you call it in your country. You take the wrapper off and you throw it in the bin. That becomes waste product. It goes to landfill. And then what somebody did as an experiment of this circular economy is, obviously it costs more money, but that was a biodegradable paper material that had flower seeds in it, and you were encouraged to throw it on the floor. So actually what you do is you have your product, which is the ice cream, you enjoy it, it's delicious, you have a great time, and then you throw the wrapper that was originally a byproduct on the floor, but actually that grows a plant, a tree, a flower, and then takes carbon out of the air and is a net contributor to that system. That's what we need to get to as engineers. We need to stop looking at growth, money, and that side of things. And how can I contribute to the system? And the system is the world, if you want to be, or even bigger, if you take SpaceX and Mars. But what can I do to make the system or the world a better place by my product being there? Not how can I make loads of money and make it cheap, but how can this be a net contributor to society and the system? So that's number three. So one is design for manufacture. Two is using AI and co-creating with machines. Three is systems thinking. And then four is this kind of the skill of, and they touched on this as well, is like collaboration. Like nobody does anything in a vacuum. So as an engineer, you're not, well, that's not true. Very, very few people are successful on their own. And it takes more than an engineer to get a product in market, to build a building, to make a film. So the value of collaboration has never been more important than it is now. Like if you look at the way companies are going, they're getting larger in size. So you have to be able to collaborate with people, and you have to be able to collaborate with people from different backgrounds, different countries, different time zones. Like right now, every podcast you've done, right? You haven't been sat in the room with those people. You have to be able to collaborate with them and talk to them and understand them and also get your ideas across. And that's the fourth skill that I think you can only kind of learn by doing, and you can't learn about collaboration. Sorry, that's not true. You can learn the theory of collaborating, but it doesn't make you a good collaborator. And that's where, again, that's where universities do add massive value, because you're a cohort of 100 or 1,000 students. So let's work on a project. Let's build something together. Let's collaborate. Let's collaborate with a machine and with others. That's where they add value, not teaching you the Hooke's law and what numbers to put in that calculation. They add value by getting you used to collaborating, working in teams, helping solve really complicated problems. And ultimately, the world's most complicated problems, climate change, interplanetary travel, whatever the thing is that you're into, that's a complicated problem, and that needs a very, very big team of people. You're not going to solve that on your own, and you're probably not going to solve it with just human power. You're going to need to use some computers or machines to do that as well. So collaboration is the fourth one.
I agree. Mike, if people have any questions or they want to connect with you or, the sort, where can people find you? And do you also have any announcements from Autodesk you'd like to make, any new projects or products or maybe job openings that you have lined up?
Yeah, so I think the best way, depending on what you're what you're wanting to achieve. Like LinkedIn, if you're looking for more a professional connection, I'm on there. So it's like LinkedIn/Mike Westlake, all one word, or just search me on there. And if you want any advice or any questions, please do reach out. And I often say that in these forums and nobody ever gets in touch. So if you really do want to, I'm more than happy to do that. I'm on Twitter if you want more of an informal relationship. And also I've got a work email address, which is mike.westlake@autodesk.com. So if you want to find out more about, directly things related to Autodesk, feel free to do that. There's the website, which is autodesk.com/education. That's where you can get access to software and learning content. So that's the way to get kind of connected with me. And again, if you just believe in some of the same stuff that I do, I'm sure there's a way we can work together and I can connect you with other students or with people in companies. And we've actually got an opening at the moment in the US for an intern to work on strategy. So if people are interested in that, please do apply for that. I posted it on LinkedIn, but again, it's manufacturing strategy intern at Autodesk on the job website. You can find that there.
What are the requirements for that job?
Oh, yeah, great point. So what we're looking for is that unique cross-section of somebody that's probably got an undergraduate degree in some sort of engineering and then is probably doing their MBA or is, looking at a business degree or working on consulting or strategy. That's kind of what we're looking for. So someone that has domain knowledge of engineering, but also understands strategy or wants to learn more about strategy and how you take stuff to that market. So that's what we'd be interested in there. And Autodesk run an internship program every year. So, if you're not ready this year, next year there'll be more job openings. And I think as well, like the more of you that figure out who you want to work for, whether that's Autodesk or SpaceX or whoever, like start working with them now, right? We have an ambassador program where you can work with us through the duration of your degree. That makes you far more employable at our company and probably more employable at other companies if you've got that experience. And don't wait until you've graduated to try and start looking out for companies. And I also think you need to make that decision like before you go looking for jobs. Like, what do I want to work in? Do I want to be, referring back to that system, do I want to be a net contributor to this world and work on some innovative thing that changes the way humans exist? Or do I want to make loads of money? And either of those are fine, it's a personal choice. But that will dictate who you work for. So if you're really interested in figuring out how we get off this planet, you should be looking at Blue Origin, SpaceX, those companies. Whereas if you're looking at, for example, changing the way we consume energy, then there's going to be a different sector of companies you want to work for. So I would really highly encourage you to figure that out. And that's not easy to figure out. So don't be disheartened if you don't know that, because I didn't know that at the age I was going through education. Realistically, you don't kind of know until you get into a job whether you like it or not. So I would really think about what you want to achieve as an engineer. Do you want to be known as the person that, how cool would it be to say like, oh, I developed, the Falcon 9, or I developed the first iPhone. Like, to me, that's more important. Like a fundamental shift in society, like and putting your fingerprints on that is, for me personally, more interesting than just saying I've made loads of money and I bought a nice house. So again, nothing is wrong. It's up to you as a personal decision, but that's what I would figure out.
I agree. Mike, thank you for coming on the podcast.